Welcome. In this video I'll be talking about solving a triangular three-dimensional system. So we will be presenting the column picture. So don't forget to subscribe and comment. So a triangular systems are a type of linear system where the equations are arranged in such a way that each equation has one more variable than the previous one. As you can see here on the screen, you have this one 2z equals 4, 3y plus 4z equals 8. So as you go up, you end up with one more variable. That's why it's called triangular, because it makes kind of like a triangular, like that, like this. Let's examine an example and find a column picture representation of the system. So they are particularly straightforward to solve using back substitution. So this system is triangular because each equation adds a new variable forming like a step-like pattern. So as you can see here, x plus 2y minus z equals 3, and 3y plus 4z equals 8, and 2z equals 4. So you can see the triangular kind of step like. So the first thing is we're gonna solve the z variable. So the z variable is easy. You just do z, 2z equals 4, and then you divide by 2, divide by 2. So then c is equal to 4 divided by 2, which is equal to 2. Then we back substitute it into 3y plus 4z. So we have 3y plus 4, 2 equals 8, and then we have 3y plus 8 equals 8, then minus a minus a, then we have 3y equals 0, and then that says that y equals 0. And of course the final step is gonna be to solve the first variable. We're gonna use the values from y and c in the first equation. Okay. So c is equal to 2 and y is equal to 0. Okay, so we're gonna do x plus 2, 0 minus 2 equals 3. Then we have x minus 2 equals 3. Then we have plus 2 plus 2, x is equal to 5. So we found that x, y, and z. And now we can do the column picture. So the column picture helps visualize the solution in terms of vectors. So as you can see, we can form it as x1, a1. So let's do it, okay? So it's going to be x1, a1 plus x2, a2 plus x3, a3 is equal to b. Then we know that x1 is equal to 5, x2 is equal to 0, and x3 is equal to 2. So we're going to do, so the final column picture can be represented as follows. So we're going to do phi You can do it as this, like this here, as you can see on the screen, 5 1 0 0, but we can do it as a column vector. So 1 0 0 plus 0 2 3 0, and then we do plus 2 negative 1 4 2, and that's gonna be equal to our b vector, which is gonna be equal to 3a4. We call it the response vector. So this equation confirms that the solution satisfies the original system, and the column picture visually represents the solution as a combination of the vectors. We can see it as follows, because 5 times 1, that's going to be equal to 5 0 0 plus 0 times the vector, that would be 0 0 0 plus 2 the scalar 2 times the vector is going to be equal to negative 2. That's going to be a 4. Now let's see, that should be equal to 5 plus 0, so it will be 5 minus 2, that's going to be equal to 3. So this should be equal to 3a4. And let's see if that's the case. So the left side high is going to be 3, and then 0 0 plus 8, that's going to be 8, and then 0 is 4. So 3a4, that's going to be equal to 3a4. So we check out, we have the right linear combination. Thank you for watching. Please subscribe and comment.